Hi, I'm Granny, and we're going down the rabbit hole of does quantum mechanics connect with gravity? As a reminder from a previous episode I did on Max Planck, a German theoretical physicist whose discovery of energy quanta won him the Nobel Prize in Physics in 1918. He is considered the father of quantum mechanics. Planck introduced the concept proposing that energy is not continuous but comes in, quote, discrete packets, end quote, which laid the foundation for quantum theory with his discovery of Planck's constant. This breakthrough marked a pivotal moment in physics and paved the way for further developments in energy quanta, which will later be referred to as quantum mechanics. As a reminder, I share in these videos in a very few minutes what scientists have been studying for decades, if not centuries. A groundbreaking milestone has taken place at Purdue University where scientists have set up an experiment involving levitated fluorescent nanodiamonds. These tiny diamonds are suspended in a vacuum, spun at incredible speeds while emitting and scattering multicolored light. The experiments were led by Professor Tongkang Li, L.I., a member of the Purdue Quantum Science and Engineering Institute. There were more than 7 members of this team, and research represents a significant step forward in the study of rotating quantum systems with gravity. The finding of this research was published in Nature Communications and can be found at www.nature.com. Please go there, especially respecting those people who are working so hard for all of us. Professor Lee said, quote, "These levitated diamonds contain spin qubits, Q-U-B-I-T-S, that enable us to conduct precise measurements and probe the intriguing connection between quantum mechanics and gravity," end quote. A qubit, Q-U-B-I-T, which is short for quantum bit, is the basic unit of information in quantum computing and counterpart to the bit, B-I-T, binary digit used in classical computing. Like they're having to come up with new definitions and wording to describe what their experiments are revealing to them. The diamonds used in this experiment were referred to as nanodiamonds with an average diameter of about 750 nanometers, or the size of the tip of a sewing needle, and were created in a laboratory, then irradiated with high energy electrons to create nitrogen vacancy color centers. That was all in quotation. Irradiated with high energy electrons to create nitrogen vacancy color centers, and that was essential for them to be able to understand what they were seeing. There were lots of challenges in just setting up the experiment, such as preventing the diamonds from being lost in a vacuum and to being able to read or understand what information that they were seeing or what they were seeing. By using a specialized ion trap, they successfully levitated a diamond in a high vacuum and for the first time observed and controlled the spin qubits within it. These diamonds were spun at speeds of up to 1.2 billion times per minute, which allowed the team to observe the unique effect of rotation. Think of gravity. Just think of what that means if you try and spin something and how gravity plays with that. So let me go back. The diamonds were spun at speeds of up to 1.2 billion times per minute, which allowed the team to observe the unique effect of rotation, gravity, on the spin qubits. Professor Lee explains that this achievement deepens our understanding of the quantum world. Knowledge is based on levels of understanding, and we have to be patient, because to understand the whole picture sometimes takes a long time and added information. When these diamonds were illuminated by a green laser, the diamonds emitted red light, quote, which is used to read out their electron spin states, end quote. The infrared laser was used to monitor the diamond's rotation. When the nanodiamonds were rotated, they scattered infrared light in different directions. Think of a disco ball and how it illuminates the room it's in. This provides information about that rotation. Think of gravity. To conduct the experiments required highly technical instruments and highly trained scientists. To honor each of them, please refer to the article I am referring to, and I mentioned where you could find it. Amazing people. These experiments could help create large quantum superpositions to test the limits of quantum mechanics and gravity. Professor Lee said of this work, quote, general relativity and quantum mechanics are two of the most important scientific breakthroughs of the 20th century. However, we still do not know how gravity might be quantized. Studying quantum gravity experimentally would be a tremendous breakthrough. Rotating diamonds with embedded spin qubits provide a platform to explore the coupling between mechanical motion and quantum spins, end of quote. He also mentioned these kinds of experiments can help with issues in navigation and communication. Currently, the theories of quantum mechanics and gravity contradict each other. There is an ongoing scientific quest to recognize these two major theories. In physics, quantum mechanics is described as governing the behavior of very small particles. General relativity describes the force of gravity on a large scale. And the contradiction is sometimes their experiments contradict each other. Scientists are trying to develop a unified theory called quantum gravity that explains how gravity behaves at the quantum level. So will we see in our lifetime, or my lifetime, which is probably shorter than your lifetime, these two theories ever explained so that they no longer contradict each other? I'm hopeful that it will be through brilliant scientists like those conducting these studies and amazing technology that it will happen in my lifetime. Thank you for joining me. I appreciate your time. Join me next time when Granny goes down the rabbit hole. Please subscribe and share. Thank you.